Hi, and welcome to the University of New South Wales at the School of Mathematics and Statistics. My name is Thomas Britz, and I'll be looking at problem number 80 in the course 3411. So, this problem here is about iterations, and in particular it's about linear feedback switch registers, or LFSRs, and what they are about is just that we have a sequence of numbers x0, x1 and so forth that we iterate or that we iteratively generate. So if we know 3 sequential values of these x's, then we can generate the next one in line by this relation here, and that's one of the examples of these LFSRs at least. So let's do that and see what happens. So we could make a little table, I and xi. Where we start off with 0, x0 is 1, x1 is also 1, x2 is 0, and for the third step we don't have any given values, so we have to use the iteration here. So here we're looking for x3, so that's where I here is equal to 0. That clashes a little bit with this one here, but so we have that the x3 term here depends on the previous 3. In particular, it's just equal to this and this term added together. So we get 1 plus 1 is 0. Now for the fourth term, we have to again take this term here and then go 3 steps back and 2 steps back. So we're looking at these two terms, add them together and you get 1, and so forth and so on. So let's continue. So we get 0, 1, 1, 1, 0, and 0. And you can continue. So this gives you a sequence of zeros and ones, and those numbers, you can consider them to be sort of random, so we call them pseudo-random. Now, if we look at the sequence of numbers, every 3 sequential numbers determine the next in line. So if we can recognize any triple along here, then we'll see that the numbers will begin to repeat themselves. So let's see what happens. We've got 110, for instance, and if you scan the line here, we see 110 over there. So these 3 determine that 0, as do this one. So if we get a repetition like that, then we'll see that the numbers will begin to cycle around, and they'll begin to repeat themselves, in other words. So we'll have a cycle of numbers, and then we can ask, how long is that cycle? What's the repetition length? And you can just see here, we started in 0 and we went to 7. So the distance from 0 to 7 is just 7. So the repetition length is exactly 7. And that's not all that bigger repetition length. That doesn't give us a whole lot of randomness, but it illustrates our point in this situation. And there we're done. Thank you very much.